Hello brother, let's take example based on your transfer function. As you said, you want example from homework side. So let's take example based on transfer function which are given in your PDF, that is homework. Okay, let's start. So your first example is they are giving network like this. Capacitor is there, right? First example, and they are giving the resistor. Then there is again capacitor, again one resistor and output. Okay, so this is the example they are giving here. They are giving as a VI of S, right, or we call it as a T, right, and this is VO of T. Okay, they are giving here value 2 nanofarad, right. This is again 2, sorry, not 2 nanofarad, this is a microfarad, right. This is again 2 microfarad. Then it is a 1 by 2 mega ohm, and it is 1 mega ohm. This one is 1 mega ohm, right. So this is the example given in your homework. First example of your homework. See, they are giving here values of capacitor. In previous example, they are giving here C. This is C1, this is C2, like this, right? C is acts as a value. We can put as a value, right? Okay, now instead of C, they are giving a value here. 2 microfarad is the value of C1, and again 2 microfarad is the value of C2, right? Here they are giving R1 and R2 two resistance. R1 value is 1 by 2 mega ohm and R2 value is 1 mega ohm, right? See, we can write down this is micro now. We put as a micro only because micro means it is a 10 raised to minus 6, right? But we put as a micro only, and instead of that 1 by 2, can we write here 1.5 because 1 by 2 and 0.5 one of the same thing, right? So 0.5 mega means 10 raised to 6, right? And this is again 1 mega, this means this is 1 into 10 raised to 6, okay? So we put as it is. Let's start. As we know, for the calculation of transfer function, we want output upon input, that is VO upon VI. For that we are considering loop. So this is your first loop where we are considering I of t. We call it as the I1 of t, right? Here we consider as a I2 of t, right? Right? And here we consider as a I3 of t. See, we are considering here I1, I2, I3. For first loop we consider I1 as a current from first loop. Second loop we consider I2 as a current from second loop, and from third loop I3 we consider as a current, right? Let's start. First, what is the first step? Apply KVL in loop 1. As we apply KVL in loop 1, what happens? See, in loop 1 there are two components, capacitor and resistor. So voltage across capacitor plus voltage across resistor is equal to VI of t, right? VI of t. VI of t is the input voltage, right? What is the voltage drop across capacitor? As we know, it is 1 upon C integration of I1 of t plus what is the voltage drop across resistor? It is, one second, plus it is I1 of t minus I2 of t into R. See, this branch, as we consider this branch, from this branch there are two current flow. I1 of t is also flow towards downward, and I2 of also flow towards upward, right? So that's why we are taking subtraction here, right? So I1 minus I2 into R, right, is equal to VI of t. Okay, let's solve it. As we take Laplace transform here, Laplace transform at both the sides, what's happen? 1 upon c is as it is. As we know, integration, Laplace of integration is 1 upon s, so we are putting 1 upon s like this. I1 of t, so we call it as a I1 of s, right? Plus, here we write down I1 of s r minus I2 of s r is equal to Vi of s. See what I do here? I'm just multiply r at both the sides. See, at both the terms. That means I'm just open the bracket and multiply r inside the bracket. So we get I1 of r and I2 of r, right? Let's common it out. What we do to common? See, I1 is here, I1 is here, so two I1s are there. So I'm putting 1 upon SC I1 plus R outside, and what is the outside here? I'm putting I1 of S outside minus I2 of S R as it is equal to V of S. Okay, so this is your equation number 1. This is your equation number 1. Let's move on the equation number 2. When we apply KVL at the second loop, what's happened? See, second loop there are three components. This 0.5 mega ohm, this capacitor, and this ohm 1 mega ohm, right? So three components are there. Let's apply KVL. See, here can we put C as a value? See, what is the value of C? Value of C is 2 microfarad, right? 2 microfarad. So we are putting this value at the last. Okay, let's start apply KVL at the second loop. Apply KVL at loop 2. Okay, so loop 2 there are 2 resistor and 1 capacitor. So voltage across resistor is plus voltage across capacitor plus again voltage across resistor equal to 0. This is resistor. Okay, so this is the R1 and this is the R2, right? Let's put the values. As we know, voltage across resistor, what is that? There are two currents, that is we are considering first current as the I2 of t minus I1 of t R plus C. If we see voltage across capacitor, that is 1 upon C integration of I2 of t dt plus voltage across resistor 2. See, resistor 2 we consider as the only same current. See, this is not your I3 current because there are no components, so we are considering as the I2 only, right? I2 only, right? So same current is there because direction of current is same. That's why I'm putting here plus again resistor, that means I2 of t R equal to 0. Okay. Okay. Now see, now can we apply Laplace here? So we are putting Laplace at both sides. Once we apply Laplace both sides, again we are going to multiply this R inside the bracket. What's happened? It is I2 of S R minus I1 of S R plus 1 upon C as it is. Again Laplace integration is 1 upon S I2 of S plus I2 of S R equal to 0. Okay. Now can we put something common? See, in the term there are 4 terms. So this is I2, this is I1, this is again I2, this is again I2. So we can put I2 as a common. So what is inside here? R is inside here, right? Plus 1 upon SC plus R. This is equal to the R1, this is equal to the R2, right? Because both the values are different, right? R1 is 0.5 mega ohm, right? And R2 is 1 mega ohm, right? And we are putting I2 of S outside minus I1 of S as it is equal to 0. Okay, I forgot to write down R equal to 0, right? Now can we shift this term towards RHS side because this is negative here. When we shift at the RHS side, it becomes positive. So what's happened? I1 of S R, right? Now for I1 of S, can we put this R? This is R1, right? So can we put this R1 towards the LHS? Because it is multiply here, right? R1 is multiply here. When we shift, it become division. So R1 plus 1 upon SC plus R2 I2 of S. Okay. When we shift this R1 into the LHS side, what's happen? 1 upon R1, it become divide, right? R1 plus 1 upon SC plus R2, right? I2 of S equal to I1 of S. See, here we get value of I1, right? Can we put this value of I1 into the equation number 1? When we put value of I1 into the equation number 1, where is equation number 1? This is equation number 1, right? So can we put here value of I1 here? Okay. So we get the I2 equation, completely I2 equation. Okay. Let's put value of I1 here. So the equation is as it is. See, put I1 of S in equation 1. Okay. When we put equation 1, what is equation 1? Equation 1 is 1 upon SC plus R I1. So I1 value is this one, right? So it is 1 upon R1 plus 1 upon SC plus R2 I2 of S. This is value of I1, right? And again, what is the equation number 1? See what I do here. I'm just putting this I1 value as we get in the equation number 2, right? Minus I2 of S. This is as it is and this is as it is, right? Okay, so it is minus I2 of S as it is R1, right, is equal to Vi of S. Okay, this is as it is, right? Now see, again I2 is common here. See, I2 is here and again I2 is here. Can we put I2 outside? Can we put I2 outside? Okay, when we put I2 outside, what we get? Okay, so equation become like this: 1 upon SC plus R1, 1 upon R1 bracket R1 plus 1 upon SC plus R2 minus R1, right? I2 of S equal to Vi of S. Okay. Now see, R1, this R1 and this R1 both are cancelled here. See, this R1 and this R1 both are cancelled here because both are negative positive. Okay. So this is your final equation. So we get here Vi. This is we get Vi, right? Once we apply KVL at the output side. When we apply KVL at this output side, this loop, what's happened? See, only one component is there, and that current value is I2. Okay. Let's apply KVL at the output loop. Okay. Third step, apply KVL at output. Okay. There are only one component, that is R2 I2 of S. Okay, one second. Voltage drop across resistance equal to VO of T. Okay. But what is the voltage drop across R2? It is I2 of S into R2 equal to V of T, right? When we apply KVL, when we apply Laplace, both sides, what's happened? See, when we apply Laplace both sides, what's happened? I2 of S will become I2 of T. One second, this is T, sorry, and it is again S, right? R2 is equal to VO of S. Okay. Now see, this is your equation number 3, right? And this is equation number. Vertical side we call as a 3 and we call as a 4 here, right? See, we want transfer function, so let's divide 4 by 3. Let's divide 4 by 3. So we get VO upon VI, right? Divide 4 by 3, right? as we divide equation 4 by 3, equation 4 is VO upon VS, right? So it is as it is VO upon, what is the equation number 3? It should be VR of S, right? Is equal to, what is the RHS? So it is I2 of S R2, right? Let's divide this by equation 3. What is the equation 3? See, equation 3 is this one, 1 upon SC plus R1, 1 upon R1, right? Upon SC plus R1, bracket complete, outside the bracket 1 upon R1, again there is a bracket, right? R1 will cancel, 1 upon SC plus R2, right? 1 upon SC plus R2, it is 1 upon SC plus R2, I2 of S, okay? Now see, I2 of S and I2 of S both are available at the numerator as well as denominator, so both are cancelled together. So what is the remaining? What is the remaining? See, at the numerator only R2 is remaining, and at the denominator 1 upon SC R1, okay, into R1 and this bracket, right? So what to do? 1 upon SC. So can we multiply this term? So 1 plus, when we cross multiply SC into R1, so it is S R1C, right? Again, can we call as a C1, okay? This is C1, okay? And this is C2 divided by SC, right? In the bracket, outside the bracket, there is a 1 upon R1, and again here can we cross multiply? So 1 plus R2, sorry, before write we call as S R2 C2 divided by SC2, okay? This is your final answer, or we can put the values, okay? What is the value of R2 here? Value of R2 is 1, okay? So we can put it only 1 mega ohm, right? So we call it as 1 mega ohm divided by C 1 plus SC, 1 plus SC. So S R1, what is the R1? Again it is a 0.5 mega ohm, 0.5 mega ohm, right? Mega, better to write down separately. It is 0.5 mega, right? And C1. So what is the C1 here? C1 is, one second, what is the C1? C1 is 2 microfarad, right? So it is a 2 microfarad, right? Divided by SC. So S into 2 microfarad, okay? That's it. 1 upon R1, okay? What is the 1 upon R1? Again R1 is 0.5 mega, right? Again in second bracket 1 plus, again S, what is the R2? It is 1 mega ohm, right? So it is mega, and this is C2, so it is 2 microfarad, right? Divided by S C2. C2 is 2 microfarad. See, brother, see, mega means 10 raised to 6, right? Micro means 10 raised to minus 6. So 10 raised to plus 6 and minus 6 both are cancelled here because both are neighbor here, right? So here mega and this micro get cancelled, right? Again here mega and this micro get cancelled, right? Again see, this is the micro, right? So micro and this mega again cancel, only one micro is remaining here, right? So what is the answer here? See, 1 mega divided by 1 plus, see, as it is 0.5 into 2, so it becomes 1, right? So not write down to write down 1, not to write down 1, okay? And S into 2 only, right? Or we call it a 2S, right? Again in the second bracket, so it is 1 upon 5 only, 0.5 only, right? And in third bracket, what is the remaining? So 1 plus C, so 1 into 2 is only 2S divided by S 2 micro is remaining. Okay, see, now we can put this 2 micro, right? So micro and mega again divide, see, division by division, right? So this mega and this micro is again cancel. Okay, so what is the remaining in finally? What is the remaining? See, one is as it is, right? So let's multiply everything. So 1 plus s into 1 plus 2s. So it is a 1 plus, see, s into this bracket. So s into s plus 2s plus 2s square, right? Divided by everything is multiplied, right? So 2s into 0.5. It is 1, right? 1s into 2s, that is 2s square. Okay, 2s square, right? Now this 2s square can be shift at the numerator, so it is 2s square divided by this 2s square plus 3s plus 1. This is your final answer. Right? One thing is again remaining, see, this 0.5, 1 upon 0.5 means it is a 2, right? So when it is 1 upon 2, right? So can we shift in the numerator, so it becomes 4. See, what is the remaining here? 1 upon 0.5 means it is a 2 remaining here, right? So both 2 and 2 get cancelled, so you get only single one. Okay, this is your final answer. Okay, so maybe it is not exactly matched with your final answer of PDF, but this is the right answer and this get full marks. Okay, let's